All right, guys, the video that we were on cut off abruptly again. I have somebody come look at my internet this afternoon. I'm so sorry. So we're going to pick up on number 3. So this is going to be part 2 of the lesson using the Pythagorean Theorem, okay? Sorry, guys. All right, so we're going to pick up on number 3. It says, draw a line segment connecting the two coordinates and then find the distance between them. So what we'll do is go ahead and draw that line segment. And we're going to find the distance between them, these two points. So here it's a slanted piece. It's going to be C. But in order to calculate this, which is the hypotenuse, I need to draw the right angle on it. So I'm going to draw the right angle that connects the two coordinates, the 2 points. And I'm going to count each side length. 1, 2, 3, 4. And this is 1, 2, 3 units long. I'm going to use the Pythagorean Theorem to figure out the missing side length, which is C. So I'll call this one A and I'll call this one B. All right, so I'm going to write 3 squared plus 4 squared equals to C squared. 3 times 3 is 9. 4 times 4 is 16 equals to C squared. These are on the same side. I'm going to go ahead and add. 9 plus 16 is 25. And then in the end, I'm going to take the square root because I don't want the square on the side of C. I don't want the square on the side of C. I only want the length of C. So I'm going to take the square root of both sides. The square root of 25 is 5. And the square root of C squared is C. So this is actually 5 units long. So the distance between the two coordinates is 5 units. All right, let's move on. All right, let's take a look at something like number 5. I'm kind of skipping around, not going to do 4. These two make the legs because they make the right angle. As you can see, the right angle is right there. So these two are my legs. They're my A and my B. Again, A and B are interchangeable. It doesn't matter which one you let be A or which one you let be B. I'm going to call 3 A and I call 8 a B. But if you go directly across from this right angle, you're supposed to get C. Well, this says K. So I don't really use K. I'm going to call this C because I don't like using any other variables. So if you see other variables, you can always switch it back to A, B, and C. All right, so now I'm going to find the distance or the hypotenuse here of this right triangle. So I have A squared plus B squared equals to C squared. A is 3. So that's 3 squared. B is 8. So that's 8 squared equals to C squared. So that's 9 plus 64 equals to C squared. Well, 9 plus 64 is 73. But I don't want the square that I would draw on this side. The square that I would draw on this side would look something like this. Okay? I don't want that. I only want this, the line segment, the side length. Okay? So if I only want the side length again, well, what are we going to do? Well, we're going to take the square root of both sides. And I'm just going to start doing this to show that I take the square root of both sides. So if I take the square root of 73, I end up with an approximation of 8 and 5/10, and it's going to be in terms of centimeters, but that's an approximation. So use your little approximation symbols instead of the equal symbol. So C is approximately 8 and 5/10 centimeters. All right, let's take a look at the next section. Since you can also use the Pythagorean theorem to find any missing leg, so not just the hypotenuse. So if you look at what we've been doing, so up here, I found the length of the hypotenuse. Here, I found the length of the hypotenuse once I drew the triangle, the right triangle. Here, I found the length of the hypotenuse. Here we're finding the length of the hypotenuse, which was the distance between those two locations. Here we find the length of the hypotenuse. Here the length of the hypotenuse. Okay, but I don't want to find the length of the hypotenuse. And keep in mind, if you're finding the length of the hypotenuse, you're given A and you're given B. Given A and given B. I was given A and given B. But if you look here, I'm not given A and B. This here is the right angle. So I'm missing one of those sides for the right angle. So I'm missing one of those values for A and B. But I'm also given this. This is the hypotenuse. So I'm given the hypotenuse and only one leg. I'm missing the measure of the other leg. All right. So I'll say this is A and I'll say I'm missing B. Now keep in mind, you could have let this section right in here be A and that section be B, but it doesn't matter. Here's my right angle. That's the L shape. So directly across from that is our C. So that's our hypotenuse. All right, so let's plug in and try to find that missing side, that missing leg this time. So still going to use the Pythagorean Theorem because it also works to find a leg or the measure of a leg or a hypotenuse. All right, A we don't know. Yes, we do. A is 5. So it's 5 squared plus B we don't know. So we keep it like that. So underneath B, you put your B, just leave it, that's your unknown. C we know, which is 13. Now, a common mistake that is made is that some students will put 13 right here because they think the numbers have to go on the same side. No, the numbers don't have to go on the same side. Only legs go on the same side together. 13 is not a leg. 13 is a hypotenuse. The hypotenuse is always on this side by itself. So do not put 13 over here. It doesn't belong there. Only legs go on this side. Okay? All right, so with that being said, let's just go ahead and fill in what we have. 5 squared is 25 plus B squared, and 13 squared is 169. All right, so I want to solve for B because I'm trying to find B. That's what I'm trying to find. I want to solve for B. So it means I got to get B by itself. Well, this 25 is keeping me from having B by itself. Now, you've learned to solve equations. What do you do to get rid of 25? Well, you change the sign. So you have B squared equals to 144. Well, I don't want the square that I would draw on the side B. Okay. I don't want this. I don't want that square that I would draw down here. I just want the side length. So the 144 is the area of the square that I would draw here if I were to draw one. But if I just want the side length, I take the square root of that area because that 144 represents area. So I'm going to take the square root of both sides. So B is 12 units. So B is 12. All right, so I want you to keep something in mind. Here, the 25 and the 169 were on opposite sides of the line. What did I do? I had to subtract. If you look up here, the 9 and the 64 were on the same side of this line. I added. The 9 and the 16 were on the same side of this line. What did I do? I added. Over here, the 24 and the 5 were on the same side of the equal sign. What did I do? I added. Here, the 16 and the 16 were on the same side of this line. What did I do? I added. So I hope you get the gist of what I'm saying. If the numbers are on the same side, that means they're both legs. Well, what do you normally do with the areas that are on the legs? You normally add. So you can add the numbers as long as they represent the areas of the legs, because that's what the Pythagorean theorem says you can do. Therefore, they will both have to be on the same side. But in this case, 25 and 169 are not on the same side. So to figure out the missing area that's on the leg, you subtract instead of add. So basically, when they're on the same side, the areas on the same side, add. When the area is on different side, subtract. Okay? Or just follow your process for solving an equation. just do the opposite to get the variable by itself. All right, here, the right angle is right here. So this has to be C. Therefore, I say this is A. I'll just label that as A, and we'll label this one as B. So we have A squared plus B squared equals to C squared. A, I don't know, so I'm going to write A squared. B, I'm going to say is 12. C is 20, so I just plug it in where it is. Please do not put C 20 over here on this side, okay? Don't put it over there. It doesn't belong over there because it's a C. C is your hypotenuse. It's always on the side by itself. Only the legs go on this side right here, okay? All right, now let's go ahead and square 12. 12 squared is 144. If you square 20, 20 times 20 is 400. Now, if you notice, these numbers are not on the same side. So what you're going to do is subtract. In other words, you're trying to get A by itself. So what's keeping you from having A by itself? That 144. How do you undo 144? A positive 144. You subtract or just change the sign. So these will cancel, and I'm left with A squared equals to 256. Okay. Now, you don't want the square that will be drawn on the side of A. You want the side length of A. So what do you have to do to find side length? Well, you take the square root. So the square root of A squared is A. And the square root of 256 is 16. I don't like that being there because somebody's going to get confused. I don't want to write this so close, y'all. Hold on. Let me erase some of this. All right, it's freezing on me, so give it a second, guys. I tell you, my internet's kind of slow, so bear with me, okay? These will cancel again. So we end up with A squared equals to 256. And we're going to take the square root of both sides. I'm just doing this where it's more room and it's not jumbled up with this shape here, that right triangle. So the square root of A squared is A, and the square root of 256 is 16. So that tells us that that leg is 16. Okay, now I'm going to do the last few. I'm not going to do all of them, just a few. It says use the Pythagorean theorem to find the missing length. Well, the difference between these here at the bottom versus these, here you have a diagram. You got a drawing. Here you have a drawing. Here you have a drawing. Here you have a drawing, a drawing, a drawing. Okay, so you have drawings for the other ones. You actually have the right triangles. Down here, there is no right triangle, but it doesn't mean you can't use the Pythagorean theorem because we still know A and B represent legs and C represents the hypotenuse. So what I'm going to do is see what's missing. Well, if I have A and B, that means C is missing. So I'm still going to use the Pythagorean theorem, A squared plus B squared equals to C squared to figure out that missing value. So that's going to be 7 squared plus 24 squared equals to C squared. Well, 7 squared is 49. Okay, let me erase that because that definitely doesn't look like a 49. All right, I'll try to get it back. All right, 49, that looks much better. And 24 squared, I think is 576 equals to C squared, okay? So I'm going to take 49 and add it to 256, and we get, 49 and add it to 576, and we get 625. But I don't want the square on the side of C. I want the side length of C. So I take the square root of both sides. The square root of 625 is 25, and the square root of C squared is C. So that tells me that my C is 25 for number 8. All right, if you look at number 9, you have a B and a C, so we're missing an A, which is a leg. All right, so I'm going to take A squared plus B squared equals to C squared and just substitute my numbers. A, I don't know. B, I know is 9, so that's 9 squared. C is 15, so that's 15 squared. So you have A squared plus 81 equals to 225. Okay, notice that A is not on the side by itself. So to get A on the side by itself, I need to get rid of 81. So I just change the sign. I'll do the opposite. So that means A squared is equal to 144. We're going to make it through, guys. I'm almost done. 144. And then because I only want A, which is the side length that's on the of that square, the area of that square, then I take the square root. So the side length is the square root of 144, which is 12. Okay, so I know A is actually 12 for number 9. Okay, I won't do 10 or 11 because they are like 8 and 9. One thing on 10 is instead of missing A, you're missing B. So it's just a little different from number 9, but you still would be fine on the leg. On 11, you're missing C, just like you were on number 8. So it's the same setup. Right, I'm going to work 12, but before I work 12, I need to go over something. All right. So if I ask you what is the square root of 5 times the square root of 5, you should at least be able to tell me that it's the square root of 25. Well, 25 is a perfect square. So what is the square root of 25? Well, it is 5. If I say, what is the square root of 7 times the square root of 7? Well, it's the square root of 49. The square root of 49 is 7. All right, if I said, what is the square root of 10 times, look at that. All right, the square root of 10. Okay. Times the square root of 10. It is the square root of 100. And the square root of 100 is just 10. I hope you all see what's going on. Square root of 8 times the square root of 8 equals the square root of 64, which is just 8. So I'm going to try to bring something to your attention. The square root of 5 times the square root of 5 basically is just 5. The square root of 7 times the square root of 7 basically is just 7. Square root of 10 times the square root of 10 is just 10. Square root of 8 times the square root of 8 is just 8. So when you multiply a number by a square root, specifically by itself, you just get the number underneath the square root symbol. That's all. That's all. As simple as it is. That's all you do. Is I can just look at this and say the square root of 12 times the square root of 12 is just 12. I don't have to put it's the square root of 144, which is 12. Now looking at the pattern, I know it's just 12. Or if I said the square root of 11 times the square root of 11, I could say it's just 11. It'd be nice if it were right correctly. Which is just 11. I feel like I'm in the classroom and I'm dealing with my smart board. All right. So the reason why I wanted to go through this is because when we do number 12, we're going to need to use that fact. All right, so I have B and I have C. And I just want to show you B looks weird. B says it's square root of 39. So I'm just going to go over here and look at what the square root of 39 is. The square root of 39 is not 39. It's 6.24499, blah, 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 okay? Because 39 is not a perfect square, the square root of it will be irrational. All right, but we're not going to round that off or anything. We're not going to write it as a decimal. over here, we're just simply going to leave it as the square root of 39 when we put it down. But you have B and C, so that means we're missing A. So you have A squared plus B squared equals to C squared. A, you don't know, so you leave it as A. B, we know, is the square root of 39. Please do not put 39 there. Put the square root of 39 squared equals to C squared. All right, so when you think about this, A squared is just A squared. We don't know it. But the square root of 39 squared, well, what does the square root of 39 squared mean? The square root of 39 squared means the square root of 39 times the square root of 39, which is just 39. So this basically is what we have been doing, and it ends up being 39. So it's basically all this stuff we were doing over here. So the square root of 39 squared is 39. So I just put 39. I don't like the way that's written. And C squared, I forgot to change it up here. Let me go back. I don't want to put 10. I want to put 10 squared. That's my fault. Probably because I'm frustrated with this thing. 10 squared is 100. It's lagging. All right, now, if I want to get A by itself, I need to get rid of 39. So to get rid of 39, I'm going to subtract 39 from both sides, okay? These will cancel. So I have A squared. Okay. You have A squared, if I can ever get it back to the pen, equals 61. And what I want to do is take the square root of both sides. If you're diligently watching this video, thank you, because I know you all are probably just as frustrated as I am. All right, so this is approximately, let me put the little approximation symbols, 7 8/10 units. All right, so if you look at the last one, some of you think, well, I don't know how to do this one. Well, just because it has decimal doesn't mean you do it any differently. All right, so you have A and B, you're missing C. So we're going to go A squared plus B squared equals to C squared. That's just write the Pythagorean Theorem down. All right, and we're going to fill in what we have. That's 6 2/10 squared plus 9 5/10 squared equals to C squared. So you take 6 2/10 and multiply it by itself. You get 38 44/100. If you take 9 5/10 and multiply by itself, you end up with 90 25/100. So when you add those two together, you get 128 69/100. Now you don't want C squared, you only want C. So take the square root of both sides. The square root of 128 and 69/100 is approximately 11, and I'm approximating to the nearest 10. So it's 11 3/10 approximately. That's C. And that's it, guys. Thank you for bearing with me.